So we're in section 3.4, and we're going to solve exponential equations. This section is not on the quiz tomorrow. So the quiz only goes through what we covered through Tuesday. All right. So today we're going to talk about solving exponential equations. On next class period, not after the quiz, on Monday, we'll talk about solving logarithmic equations. And we're using the same ideas for both of them. We're using basically four different properties. So one of the important things that we've talked about with exponential and logarithmic functions is that they are one-to-one. So one of the properties that we'll use are the one-to-one properties. And the one-to-one properties just mean that one-to-one means for every x, there's exactly one y. So that means a to the x equals a to the y if and only if x equals y. That's what one-to-one means. If we get the same thing out of the function, it means we have to be plugging the same thing in. And the same is true for logarithmic functions. Log base a of x equals log base a of y. If and only if x equals y. So this is one of the properties that we'll use to solve exponential and logarithmic equations. And notice here that for both of these, the bases have to be the same. So the bases on both sides of the equation are the same. So we have to have the same base on both sides of the equation for this to work. So that's one set of the properties that we'll use. The other set are the inverse properties. And the inverse properties basically tell us that inverse functions undo each other. So that means log base a of a to the x equals x. And we can do the same thing, a to the log base a of x equals x. Inverse functions undo each other. And students, a lot of times students say, oh, they cancel each other out. Not really canceling. One does the opposite of the other. So it's kind of like canceling, but technically it's not canceling. All right, so all I want to do is go through a few examples today of solving exponential equations. Show you several kinds of examples of the types of equations that you might see that involve exponential functions. And I want to give you some guidelines to solve these equations. These are a lot like solving trig equations, where there's not a set procedure you use every single time. What are guidelines? We want to isolate the exponential function. And when we say isolate, what we mean is we're getting it by itself on one side of the equation. And then we can think about it a couple of different ways. We can take the logarithm of both sides. So that's one way we'll do it. The other way we could think about this, and when we go through them, I'll show you both ways, just so you can see the two different ways. We could also, once we isolate the exponential function, rewrite in logarithmic form. And then sometimes you can use the change of base formula, depending on how the equation works out. So these are our guidelines for solving these equations. So I just want to go through a few examples, and then we'll have plenty of time to practice and ask questions afterwards. So are we good with the guidelines? All right. So let's look at some examples. We want to solve on all of these. We're solve 4e to the 2x equals 16. All right, so what's our first step here?
Divide by 4.
Isolate, so we want to divide by 4. So e to the 2x equals 4. So we have our exponential function isolated. We have it by itself on one side of the equation. And now the way I usually think about this, and this is just personal preference, I usually think of taking the logarithm of both sides. So I would say the natural log, and why did I use natural log? Because our base is e, right? Natural log of e to the 2x equals natural log of 4. And I like to think about it this way, just me personally, because our normal procedure for solving equations is we do the same thing to both sides. So we're taking the logarithm of both sides. That's just the way I think about it. All right, so what's the logarithm of e to the natural log of e to the 2x? So 2x, that's using the inverse property, equals in the natural log of 4. So x equals natural log of 4 divided by 2. And if I plug that in my calculator, if it says give your answer, this would be an exact answer. If it said give your answer to 3 decimal places, you plug it in your calculator, and we get 0.693. All right, let's go from here and use the other procedure, rewriting in logarithmic form. How do we rewrite this in logarithmic form? I'll get us started. Natural log. Do we want to rewrite this in logarithmic form? Natural log of natural log of 4 equals 2x. We're just rewriting this in logarithmic form. And so x equals the natural log of 4 over 2. We get to the same place. Sometimes this is shorter, easier, but based on what just happened, this one might be easier to think about. That's just but they both work. They both get you to the same place. All right, questions on that example? All right, let's look at another one.
Were you at the loaded time?
Yes. All right, we want to solve 5e to the x plus 2 minus 8 equals 14. All right, so what do we do first here? Isolate, so I'll add 8, so 5 e to the x plus 2 equals 22. E to the x plus 2 equals 22 fifths. So which technique do we want to use here? Take the natural log of both sides. So I get the natural log of e to the x plus 2 equals natural log of 22 fifths. Natural log of e to the x plus 2 is x plus 2 equals natural log of 22 fifths. So x equals natural log of 22 fifths minus 2. And I put that minus 2 way over there to remind us it's not part of the natural log thing. And then we calculate that out, so x is approximately equal to negative 0.518 if I calculate that. From here, the other way that we could do this one is rewrite this in exponential form. So if I rewrite this in exponential form, I get the natural log of 22 fifths equals x plus 2. And I get to the same place. X equals natural log 22 fifths minus 2. Both are accomplishing the same thing. All right, questions on that one? All right, this next one is a little different, where we'll use one of our other tools here. We good here? I like these kinds of equations because you have to think about them just a little differently than other kinds of equations. All right, so we want to solve 2 times 3 to the x minus 1 equals 10. So here we have 3 to the x, so it's a little different. So first step, isolate. So I get 3 to the x minus 1 equals 5. So 3 to the x equals 6. So what are we going to do here? Change it to, do you want to do logarithmic form first this time? Okay, let's do logarithmic form first this time, and then we'll do it the other way. Rewrite this in logarithmic form. Log base 3 of 6 equals x. That would be our exact answer. What if our problem said write it to 3 decimal places? Change your base. Then I would use change your base. So I'm going to say COB for change your base. So x equals, and I use a change of base formula on this. So what would this be? Log 6 over log 3, or natural log 6 over natural log 3, which is approximately 1.63. Now if I use the other technique here, and Ms. Lindgren, I forgot to do what you asked me about in email. I can do it during this class.
I'll just email it quick as well.
So we're going to take the logarithm of both sides. You want to do natural log or log base 10? Natural log. So the natural log of 3 to the x equals 6. And now we're using properties of logarithms. What do I do with this exponent? It becomes multiplication. Oh, I do have to take the natural log of 6. Do the same thing to both sides, right? And then I get x equals natural log 6 over natural log 3. Exactly where we were before. So either way works. Either way will get you where you need to go. All right, questions on that one? All right, this last one is a little trickier. All right, what do we do here? I'm hearing a nice word out there. So if we add 20, we're kind of stuck because we have an e to the 2x and an e to the x. So we want to factor. Let me rewrite this a little bit. This is e to the x squared minus e to the x minus 20 equals 0. So when I raise a power to a power, I multiply the exponents, right? This is the same. We did some of these when we did trigonometric equations. This is the same as x squared minus x minus 20 equals 0. But instead of an x, I have an e to the x. So how do we factor this thing? Let's do the x one first. Minus 4 plus 5. So this is going to be e to the x minus 4. So minus 5 plus 4? Yes, it would be plus 4 minus 5. You're right there. To get our signs to work out right. E to the x plus 4, e to the x minus 5 equals 0. So now this tells us that e to the x plus 4 equals 0, or e to the x minus 5 equals 0. All right, let's work on this one. E to the x equals negative 4. Anybody see a problem here? Exponential function is never negative, right? Exponential function is never negative. The other way, if we kept going, I would take the natural log of both sides. Can we take the natural log of a negative number? No, because the domain of the logarithmic functions are x greater than 0. So this gives us no solution. Now let's work on this one. E to the x equals 5. Take the natural log of both sides. So x equals natural log 5, which is about 1.609. All right, questions? Okay, that's all we have today.